Welcome to my class. Today's topic is AI Unveiled from Foundation to Future, a journey through artificial intelligence for professionals, beginners, and experts. Today, I will give an overview of artificial intelligence, what we should learn, what would be our focus area, and within short period of time, we will learn almost everything in this artificial intelligence to enter the market. So let us start. Artificial intelligence starts with a simple concept is known as decision boundary. In this two figure, that is the figure one, and this is figure two, you will get orange dots and blue dots. These are the two class, that is class A and the class B. And algorithm will learn how to separate these two classes. Actual boundary you will find in the dotted line, and the two algorithm is basically creating the boundary or the decision boundary to separate these two classes. So what exactly is happening in this artificial intelligence? We are giving the data set and the algorithm will automatically learn from the input data the decision boundary to separate the two classes. This is popularly known as classification problem. So let us enter to the popular area of artificial intelligence. So in this slide, we will learn the three layers. That is the foundation layer, application layer, and the frontier layer. Foundation layer is for the beginners, application layer is for the professionals, and frontier layer is for the experts. At the same time, I will discuss today about the future vision that is from 2025 to 2030. Let us learn first what is AI. The branch of computer science called AI is said to have been born at a conference held at Dartmouth, US in 1966. So according to Douglas Hofstadter, a well-known American scholar of cognitive science, physics, and comparative literature, AI has the following characteristics. Number one, to respond to situation very flexibly. And number two is to make sense out of ambiguous or contradicting messages. And what is machine learning? So here I have given a diagram. If you check, this artificial intelligence is the set. The subset of the artificial intelligence is machine learning. Representation learning is a subset of the machine learning, and deep learning is a subset of the representation learning. What is machine learning? The machine learning means a machine will learn. From your input data set, the machine learning will learn a hypothesis function to separate two classes. Just now I have shown you how an algorithm is building gradually or learning gradually the decision boundary. Similarly, it can do the regression problem. Say you are giving the data and from it, it is saying if it is this input, then the corresponding output will be this. So what is the classification and the regression? In the classification and the regression, we have a target color. In the classification problem, we have the discrete values, say 0 or 1, A or B. Say the input data will belongs to class A or class B. So this is a discrete value. So this is known as classification. If we have only two levels, say 0 or 1, yes or no, class A or class B, this is known as binary classifications. If we have class A, class B, class C, or say, uh, uh, then it is known as multi-level classifications. Or at the same time, the machine learnings says, as per the Arthur Samuel mentioned in 1959, so machine learning is a field of study that gives computer the ability to learn about being explicitly programmed. So it's just like, if then logic, if we are considered. See, if it's the condition, then this will be the outcome. The problem is in if then logic, there will be numerous combinations. So it is extremely difficult for a developer to write all possibles, if then logics. So machine will learn automatically. Learn what? It will learn a hypothesis function from the input data set. And based on this hypothesis function, it will predict if it is this input functions, if it is the input data, then this will be the output. For instance, you can take an example of the COVID patients. Some inputs are given, symptoms are given. So based on that, the computer will say, well, if it is a symptom of the patient, then he is a victim of COVID, or he is not a victim of COVID. So this is basically a binary classification because we have the two levels. Now, what is deep learning? Now, deep learning is basically the subset of representation learning, or it is a subset of machine learning, or I can say it is a subset of artificial intelligence. So deep learning, we have the two definition. One is the conceptual definition. So deep learning is a computer program that can identify what something is. Another one is the technical definition. Deep learning is a class of machine learning algorithm in the form of neural network that uses a cascade of layers of processing unit to extract features from data and make predictive guesses about new data. So one thing is clear, that is deep learning is a subset of machine learning, but we are still in doubt what is neural network. So in the next slide, I will explain about the neural network. So this is the neural network. Left hand side, I have the biological neuron. In our brain, we have thousands and thousands of neurons. I am talking to you. I am detecting a figure. I am detecting everything. That is the figure recognitions. So everything we are doing with the help of these neurons. Now, this is the mathematical representation of this neuron. It is basically the replica of this neuron. What we have? Input layer, hidden layer 1, hidden layer 2, and the output layer. Now, if we consider the hidden layer, only one hidden layer, one input layer, one hidden layer, and output layer, it is known as feed-forward network. Now, feed-forward network is the foundation of another well-known technology is known as large language model, because so many large language models are based on the transformer. Transformer means it has the encoder and decoder. And in this encoder and decoder, we have the feed-forward neural network as well as the self-attention mechanism. So a lot of new terminologies you may get, so don't get confused. So let us start with the neural network. What exactly this one? I am taking input x1, x2, x3, three input. I am multiplying it with weights w0, w1, w2. Initially, I am taking the random values. Now, after that, what I am doing within the cell body, I am multiplying it wi with xi, means it summation of I. This is the summation sign. So if you expand it, it will be w1 x1 or w0 x0 plus w1 x1 plus w2 x2 plus a bias b. Then these will pass through a activation function. These activation functions will give a final result. So in a neural network, basically, this is a neural network x1, x2, x3. I'm taking these weight vectors w1, w0, w1, and w2. I'm passing it through the activation functions, and then we are getting the final results here. Wait, how we are getting it? We have the two processes. One is the forward propagations. It is known as the prediction. So I'm taking x1, x2, x3 multiplied with w1, w2, w3, and it will pass to these activation functions, and then we are getting the final output. We are measuring this final output with a given data. That is y predicted is the predicted value, y is the actual value. So we are calculating the error. What is the error in our predictions? So this is known as forward propagation. So please take this means animated picture. Now we will start the backward propagations. From this error, we are moving to this next layer. Then we are going to this next layer. Then we are going to this next layer. But what exactly we are doing? We are basically adjusting the weight vectors like the W1, W2, W3. Because if we adjust these weights, the predicted value will be adjusted, will be closer to the actual value. So error will be reduced. So while you are learning the neural networks, please keep in mind here we will get the two propagation, forward propagation and backward propagations. And it is also connected with another term, that is vanishing gradient. Just keep in mind, because this is the first class, so just keep in mind this term vanishing gradient. In the next class, I will explain the meaning of vanishing gradient. Now, this is all about the activation functions. We have almost 31 different types of activation functions. Now, I'm considering a function fx is equal to x. Means if you give 1, x equal to 1, you will get 1. If you get 2, you will get 2. Now, next I'm getting the binary step. Fx equal to 1 if x is greater than equal to 0. Means I'm giving a threshold value. So based on that, it will predict. Say if x is equal to -1, the predicted value will be 0. If x is equal to -2, predicted value equal to 0. If x is equal to 1, predicted value equal to 1. If x is equal to 2, predicted value equal to 2. Now the next one is very popular, is known as sigmoid function or the logistic function, is fx is equal to 1 plus 1 upon 1 plus e to the power minus x. So if I give the value of x here, it will calculate e to the power minus x, then it will add it with 1, then it will take its reciprocals. This sigmoid logistic functions particularly used for the binary classification. Then we have the tan hyperbolic function. What is tan hyperbolic function? That is fx equal to e to the power x minus of e to the power minus x, e to the power x plus e to the power minus x. Then we have the ReLU, that is max of 0 and x. If x is negative, so the max value is 0. If x is positive, then max value is x. Then we have the leaky ReLU, because in this ReLU function, ReLU full name is rectified linear unit. Leaky ReLU is if we are taking x is negative, then in that case the value will be 0. So what we can do, if x is greater than 0, if x is equal to x. If x is negative, then it will be multiplied with a scalar value alpha x, and the alpha value means is a scalar, the value can be given or it has a default value. Then we have a softmax, that is softmax x e to the power xi divided by summation of e to the power xj, that is particularly used for multi-class classification. And there is a soft plus, that is logarithmic ln 1 plus e to the power x. We have another said like this ALU, exponential linear unit, SELU, scaled ALU, then parametric ReLU, Swish, JLU, Gaussian error for linear unit, and particularly it is used for transformers. Transformer, please keep in mind. SELU, that is this, or SELU, that is Swiss LU, means it's a modification, you could say, of the sigmoid function. Sigmoid function is 1 divided by 1 plus e to the power minus x. Now CLU is x multiplied by sigmoid function, we could say. It has been developed by the Google researchers. Then we have the soft sign x divided by 1 plus mod of x, alternative to tan hyperbolic functions, then max out, mesh, etc. So when we are studying this activation functions means, in the previous slide we have shown, we are giving this input x1, x2, x3 this way. It will be multiplied by this weight vector w, that is w0 x0 plus w1 x1 plus w2 x2 plus a bias vector. Then it will pass through this sigma, this, you know, activation functions. Let us consider it will pass through the sigmoid function. So what will be the output? 1 divided by 1 plus e to the power minus ax. In this ax, what will insert? The value of w0x0 plus w1x1 plus w2x2 plus b. So we will get the final results. That is whether it is belongs to class 0 or class 1, class A or class B, this way. Now, when we're getting the data, that is, you should study also the 7 golden steps of the data science. Here I have, prepared a simple approach. That is, I will take this input data, then I will process it. Then from this data, we will learn, and then we will give this output. So input data, when we were taking, this input data could be in the tabular format. Generally, we use for the supervised learning, that is classification, regression, etc. It could be the text data. Say, for instance, you are giving a PDF file, means you are giving a book to learn, means asking this, giving instructions to the computer to this learn from this textbook. So this is, you are giving the text. This is unstructured data. And at the same time, you can give the video as well as this audio to the, computer so that it could learn it. So I'm taking a simple example, that is email spam detection. That is email. I will give this content of this email to the computer. So it will detect whether it is a spam or not, yes or no. So what type of problem? It is a classification problem, yes or no, because it is discrete. And next, if we study further, so it must have a tabular data structure. At the same time, it must have a label column. In the label columns or the target columns. So in the target columns, we are giving in the means input data set. So what type of problem it is? It is a supervised learning. And machine learning can be broadly classified as supervised learning, unsupervised learning, and semi-supervised learning. And the last step is reinforcement learning. Supervised learning means in the input data sets, we will give a target column. Just now I said. So this target column is nothing but a teacher, a supervisor. It will guide the algorithm. If it is this input data, so this will be the output. In unsupervised learning, the target column is missing. That is unsupervised, means supervisor is not available. So based on this input data set, the machine learning algorithm will do the rest of the work. Say, for instance, I can take an example of clustering. Say, I will give the data, the computer will cluster, means group the similar items. Okay. Now, semi-supervised learning means it's a combination of the two extremes like this, supervised and the unsupervised learning. Means in some data sets, it has the label data. In some cases, it doesn't have the label data set. Now, the reinforcement learning. The best example could be, say, for instance, if you ring the bell, your pet dog will come and you will give your dog a piece of bread. Do the experiments for the 7 days. After that, if you ring the bell, the dog will automatically come and the saliva will come from its mouth, because it learns from the external stimuli, that is the bell. So if you ring the bell, the dog will come and the dog will realize, well, this is the time to get the award. What is the award? It is the bread. So let us come to this example, that is email spam detection. As I said, it is a supervised learning problem. So I'm giving the email text and the metadata. So then I will pre-process it. I will do some kind of processing. I will check this, use some statistical approaches. It is known as the exploratory data analysis. Now I'm peeling off the artificial intelligence. So artificial intelligence is basically dealing with the data. And at the same time, we are applying some algorithms. It is true. Third thing is we are using some transformation using the statistical method. So we must know the statistics. Fourth one is we are using the mathematics. Let us consider the matrix multiplication, transformation of data. That's why I'm saying. So we will transform the data and we will select a suitable algorithm. Then we will get the output. But when we are getting the output, in the last slide we have shown we are getting this error. So we need to measure the error. What is this accuracy of the model? So it is a classification problem. Some matrix we should use like F1 score, confusion matrix, recall, precision, etc., etc. If it is a regression problem, then we should use root mean square error, RMSE, mean square error, MSE, mean absolute deviation, MAD, mean absolute percentage error, MAPE, etc., etc. Now, AI versus machine learning and the deep learning. Traditional AI, when generally we are supposed to use this if-then logic, this like chase program you can consider, it has this limited adaptability. In the machine learning, the machine will learn from the data. It will learn the pattern. Now, the term pattern, it may create the confusions. So if you get an input data sets like the supervised learning, if you open it, if it is in the CSV file format, then if you open the data sets, you will get X1 features, X2 features, X3 features like this one. This is nothing but the columns. And final column, you will get the target column. The target column says it is a classification problem. So discrete data set, it will say it belongs to class A or the class B or the class C, etc. So each feature except the target column in the Excel sheet is nothing but a pattern. So each feature contains some hidden informations. So machine learning will use these features. From these features, it will use the statistical analysis, mathematical analysis, and create a hypothesis function. Let us consider y equal to mx plus c. So y is given, x is given. Y is the supervised column or the target column, x is the input data or the feature. So the computer has already established the hypothesis function mx plus c. So moment you will give x, so it has already calculated m and the c. So it will put the value of x, then do the rest of the things. It will say, well, the value of y is this. This is a similar simple regression problem. Now, when the deep learning comes into the pictures, means in the machine learning, the problem is we need to create the features as much as possible, to explore the model to the computer. Now, in the deep learning, the feature engineering or the generating features is not required. It will learn automatically from the data set. So that's why it's very, very popular. So neural networks, I have shown to you AlphaGo and the GPT. GPT, the moment ticks in your mind, that is the chat GPT. Today, we are gradually moving from traditional AI/ML approach to large language model based approach. GPT is nothing but a large language model. It is based on the deep learning network, particularly transformer. As I said, feed forward neural network and attention mechanism, precisely self attention mechanism or multi head attention mechanism. So gradually we will learn the traditional AI, machine learning, and the deep learning. So let us come to this enterprise AI landscape. First one is intelligent automation, predictive analytics, co-pilot and assistants, generative AI, and the computer vision. Intelligent automation means you will give the task, computer will automatically complete the task. For instance, sending emails. They see these things happen, so it will automatically send emails to all the stakeholders in a business. How is it possible? So today we are creating AI agents. Agent is nothing but a computer software program. In a simple way, we could say it has a memory, so it will keep everything in its memory. It will expand the memory, it will load the memory with the new data set, and it will keep in mind, well, these things I need to do. Now, intelligent automations, when we are discussing way, so just keep in mind a term N8N. This is a buzzword in this automation industry. Another term is MCP, Model Context Protocol. What we are doing, what is Model Context Protocol? It's nothing but in a simple way you can say you are using a extended cord or a spike boosters. You will see the multiple plugs are there. Okay, so if you plug it and switch on, so another device will be connected. Similarly, in model context protocol, it is a protocol. It will help different agents to communicate with each other. Large language model can give instructions or communicate with these agents, AI agents, with the help of MCP. So it is a protocol, it is giving guidelines, and it is helping large language model, then agents to interact with each other. Predictive analytics. What is predictive analysis? We can broadly classify the machine learning, as the predictive analysis and the prescriptive analysis. Predictive analysis means we have the past data. Based on that, we are saying, okay, tomorrow it will happen. So we know the price of oil today and what would be the price of oil tomorrow. This is comes under the purview of the predictive analytics. For instance, we know the weather data. We have the past weather data sets. Now we are predicting in the next 5 days, this will be the condition of the weather. Now, what is prescriptive analysis? Prescriptive analysis is quite different. Now, it is not only the predict, at the same time, it will guide you, it will help you what to do. So that's why prescriptive. Say, for instance, you are using different mathematical optimization solver like this IBM iLog, Simplex, Groby, SCIP, open source solver, etc. with the predictive models. So you will get the guidance. Well, if it is a situation you need to take this type of steps. So this is known as prescriptive analysis. Now, what is AI copilots and assistants? You are writing the code. Now just imagine you are giving instructions to the large language model. Could you please write a program in Python or in Java or in C++ to solve such and such problem? You are giving text input. Your large language model will give the output, yes, I can. Then it will write the error-free code in Python or in Java or in C Sharp or in the C language. Then what you need to do, you just take the copy of the code, you read it, understand it, manually correct it because this is required, and then you use it. So this is known as copilot or the assistants. Now, let us come to the another very important term is known as generative AI. Generative artificial intelligence. So let us take an example. That is, you will write the statement. It is also technically called as prompt. You will see the prompt engineering. Prompt engineering. What is the prompt engineering? In a simple way, you are writing text in simple English or in your mother tongue, say in German or in French, and you are giving instruction to your computer, you need to do such and such things. Just now I said in the AI Copilot, that is write the code in Python. Similarly here you can say this is the instructions, this is the description of an image, generate this image. So it will generate this image from the text. It is known as text to image generation. A wonderful technology is behind this is known as diffusive algorithm. This is very important. At the same time, for instance, say, take an example of the generative AI. You are giving a data, and from this data, it is creating the replica of the data. It is generating a new data sets, and then it is comparing what is the difference between the actual data sets and the generated data set. Is there any error? So this error, it is learning. Once it is learning, then it is modifying it, it is tuning it. This comes under purvey of generative AI. Large language model is also a type of generative AI because it is generating the text, it is generating image, it is generating PowerPoint presentation, etc., etc. Then computer vision. For instance, let us take an example. Is a very popular example is image of cats and dogs. If you check it, and you can say, well, this is the image of cat, this is the image of dog. Now, can computer differentiate it? Yes, it can. But remember one thing, this computer can only understand the mathematics. It can only understand the number. An image is nothing but the collection of floating values. Okay, RGB, red, green, blue. So when you are getting these images, computer will convert it to this number, then it will do some mathematical analysis. It will create, it will understand this mathematics, and based on that, it will say, well, it is the image of a dog, if it is the image of a cat, etc. Okay, so this comes under the computer vision. Computer vision is a very vast field. For instance, in medical sciences, say for instance, if you give the MRI images, it can automatically detect the lumped region, means where any kind of disease has been formed or not, etc. It has all means in the robotics also you will get this application of the computer vision. Now, in everywhere you will find this uh, accuracy, 85%, 79%, and this 99.9% accuracy. What is the term of this accuracy? It's simple. Let us consider you are giving value. The output will be 1, 2, 3, 4, 5, 6, like this. And the computer is giving the value 0.99, 0.95, etc. So, what is the error? Error is nothing but actual value 1 and the difference is the predicted value 0.9. Now, when I'm saying that is the error, there are different approaches to calculate the error. You can take the mode value. You can take the square of the differences. Okay. So based on that, we can say, well, this much accuracy we have, this much error we have. Now, industry transformation stories means so many of you must have heard about the Industry 4.0, Industry 5.0. So, Industry 4.0 is basically the application of the artificial intelligence and high tech. Industry 5.0, basically, we are using the high tech artificial intelligence and at the same time, human safety, human collaborations, etc., ethical use of AI. So, we can use in artificial intelligence in the manufacturing sector, in the healthcare sector, financial sector, retail sector, etc. For instance, in the manufacturing sectors, you want to optimize this inventory use, you want to reduce the idle time, you want to maximize the throughput. Everywhere you can use the artificial intelligence. It is a combination of the predictive analysis and the prescriptive analysis. You can use this recommender, you can use the large language model, etc. Now, healthcare, I mentioned already that is the COVID patients you are detecting whether he has the COVID symptoms, yes or no. These are healthcare applications. A lot of healthcare applications you can check. Say the today, you know, you will get the application of the AI to detect your heart rate, to detect your, pulses. It can detect the cholesterol level, etc. Recently, I got an award from this Kaggle for the you know, prediction of the diabetes. Earlier, I cracked the record of this Kaggle. You can check my GitHub repository to predict this diabetes. I secured this 92 point some percent accuracy using a rule-based approach. It's a very rare approach. In the financial sectors, you can say you are predicting the stock market price is a very specific example. You have created a large language model. You are explaining everything in a text. It is known as prompt engineering. And using this prompt engineering, you are giving instruction to the large language model. Well, if it is this, the company, they prepare, a financial report, so it will prepare a financial report. Now, retail. Now, in this retail sector, say for instance, you are using, three-dimensional visualizations of a flat. Customer is far away from the site. He cannot visit, so he is means requesting the promoter to use some kind of 3D representation. So you are using the 3D representations. 3D is nothing but the 2D, and if you clubbed it with the third dimension, you will get the 3D. Now, retail is means you are going to purchase a flat. Based on that, you are saying, well, if it is a flat, if it is my criteria, is it suitable? Yes or no. So it is a classification problem. So computer will say, well, it is suitable, or no, it is not suitable. Say at the same time, these are the same means some features or pattern of a particular flat. So it will be the corresponding price of the flat. So you can predict. So the predictions is basically belongs to a regression problem, because the final value, it is continuous in nature. It is not discrete in nature. So finally, the professional skills for the AI era, the number one is the prompt engineering. It's nothing but is this plain text. The prompt engineering is nothing but the plain text. You just log into this chat GPT, write anything in English, give instruction to the chat GPT will do it. Now, data interpretations. You use the prompt engineering, give the data to the large language model. The large language model will do the everything, that is the end-to-end implementations. I repeat here, I need to correct here, because it cannot upload the model to the particular website. It is true. But at the same time, it will write the Python code. It will do everything. Then what you need to do, as per the instructions of the large language model, you need to run the model. You need to create the model. Once you create, then you need to log into a particular site. You need to upload the model. That would be the end-to-end application. Now, ethical AI, it's very difficult to understand. Say, for instance, the facial recognitions, you know, then use of artificial intelligence to control or to manipulate a person, etc., comes under the purview of ethical uses of artificial intelligence. Human AI collaborations, as I said, it's very popular in Industry 5.0. You can check my paper, that is, I have integrated the adaptive RAG, multiple criteria decision analysis, along with this large language model. I use the multiple large language models like the DeepSeek, the Mistral, the large Llama, etc. Now, what kind of roles you can play? Initially, you can work as an analyst, then you can work as a manager, you can do a lot of creativities, and you can also work as a developers, which is not included here. I do not include it here. If you wish, you can use your AI skill set to start your own startup. Just Google and check the teenagers. List of teenagers have earned lot of money by using their AI skill set. So finally, the advanced AI structures and researches. What is important? That is number one, as I said from the beginning, that is attention mechanism, self-attention mechanism, and the multi-head attention mechanism. Attention means what? Focused. See, I am giving a word to the computer. I want to visit the bank of river. So this bank means is riverside. And if I give the next sentence, I want to visit bank. This is also bank, but it's not the river bank. So in this case, computer will be in confusion. So attention mechanism means we are giving focus to a input sentence. And from this input sentence, we are calculating the score. And based on the score, we are calculating the contextual relevance contextual relevance is very important in a sentence, particularly when we are doing the machine learning translations. For instance, if you open this Google, you will find, say you are writing something in English, you want to convert in German, you want to convert it into French, you can do it easily. So this is known as machine translation. In the machine translation, the contextual relevance is very important. That you can learn from the self-attention mechanism. So self-attention mechanism, mechanism, multi-head attention mechanism, and transformer is very, very important. Then scale law means more parameters, more data, it will create problem. So we need to find some techniques to deal with lot of features and lot of data. Sometimes it's called as, big data analysis. Multimodal fusion. Multimodal. If you learn anything, you learn from the word multimodal. Multiple mode means it could be text, it could be image, it could be audio. Okay. So emergent capabilities like few shot learning, chain of thought, in context learning. It is very, very important and it's relevant to the large language model. Those who are willing to learn large language model, so keep these terms in your memory. Few shot learning. Few shot learning means in a large language model, we have lots of words or tokens. So when we are giving any instructions in English to the large language model, it is known as the prompt. So it will learn automatically from the input prompt. At the same time, it will consider all the billions of tokens. Now, in the few shot learning is the things we are giving, say a large language model we have trained with different applications. Now we are giving a new application, and with these new applications, we are giving some 2 or 3 examples so that it could learn automatically. It is known as few, and short means some examples. Now, chain of thought. Chain of thought means it is very difficult for any computer to solve a very complicated problem. So what we need to do, we need to break it to small problems. And we link these small problems in a chain so that the computer could understand. Say, for instance, I'm saying, say, multiply x with y, then take it square. So what would be the instructions? First, take the input of x, take the input of y, multiple x and y. Then what you need to do? X and y multiplied. Say, let us say the multiplication's value, if we store it to the z, then z multiplied by z is nothing but x multiplied by whole square. So what I'm doing, I'm breaking the task. It is known as chain of thought reasoning. In context learning, that is this adapting with parameters update. In context learning, it is a very new field. It's a very competitor of the prompt engineering. In a simple way, I could say that is in the prompt engineering, the large language model is doing a lot of tasks. At the same time, it is keeping when some informations in the memory each time. So next time when it is getting any task, it is checking whether this type of context have I worked earlier. If it is yes, so from the memory it is giving the input, it is taking this input and do the rest of the task. Now research frontiers, that is the neural architecture search, NAS, AI designing, AI architecture, mixture of experts, that is you can consider number of large language models are working together. Say it is a group decision models, you can say simple way this way. It is a little bit different from the mixed means group decision models. In the mixture of experts, say for instance, large language model is generating a response as per the prompt or as per the given input in simple English. I'm considering from this user. And then the 2 or 3 models are verifying the output with a score. Well, this is means it is a judgmental type. You got my points. You are getting an output, and say two and three different LLM models are saying, say, well, this is the output. In five scale, I can give three, I can give four, or I can give a two. So this way they can means evaluate the output. Now, mixture of experts when you are learning, it's a very latest approach. So another one is retrieval augmented generation RAG. RAG, it is I should say this knowledge beyond the training data. What exactly is happening? You have a textbook in your hand. You have gone through, but this you will say the textbooks. The version is given version 1, version 2, version 3. The author is continuously updating the content and giving its different version. Similarly, in a large language model, it's prepared with the billions with the tokens, but at the same times it has some limitation. It has limitation related to its capacity. So when we are going to use this large language model for a particular domain, in that case we need some external data sets to you know create a robust knowledge database. In that case, the large language model will use its own knowledge, that is the billions of tokens or the words, and the same time it will consider the input data sets. Okay, so that's why it is called retrieval augmented generation, RAG. So RAG is different version. There are total 16 or 17 different types of RAG, like the simple RAG, adaptive RAG, then CAG, knowledge graph based RAG. Knowledge graph based RAG is quite popular, and because it can deal with this lot of data set. So that's all in brief for this slide. And please read, because everywhere I have given this expert perspective. That is, we are moving from training models to growing intelligences. Now, here I will use a word. Do you think the large language model has inherent intelligence? So my question is seems to be very simple. So use ChatGPT if you are not a user. So use it today and try to find out its level of intelligence. One topic is not touched here. I didn't mention, so please note it. The large language model has a problem. It is known as the hallucination. So hallucination means sometimes it is generating, garbage responses. In that case, what we need to do, we need some, mixture of experts to evaluate it, to check it. What is the quality of the response? Whether it is carrying any, hallucination, yes or no. So when I'm saying whether it is means carrying any hallucination, yes or no, it means it is a binary classification problem. So even in the large language model, we can use the binary classification model that we have studied earlier in machine learning. But here the approach will be a little bit different. It will be purely based on the prompt, means simple text. So AI ethics and explainability. So that is the black box problem. That is the deep learning models with billions of parameters, decision making process often it's not clear to the people. So what you need to do, we can do the hand calculations. Long back I started this approach for the machine learning, for the deep learning. Use your pen and papers and try to solve toy problems, and it will give you immense knowledge. Now, what is this emerging solutions? That is, explainability. That is called the SHAP lime. Generally, we use the SHAP or the lime, with the machine learning. When we are generating a lot of features, we can rank the features and we can select this is the features based on the target values. So they have superb influence on this target. So we need to check, we need to select these features for the final model. Attention visualizations, okay, and the counterfactual explanation, that is the what if analysis. What if analysis, you can do it with the large language model. Then regulatory landscape 2025, that is algorithmic accountability, bias auditing, etc. I would include one thing here that is, I recently I got the chance to interact with this client. It is known as the Alasia. Alasia training is very, very important, is particularly the AI ethnics and explainability. You can use the SHAP, LIME, etc. Then sanity check with the SHAP and LIME. I will include this part also for my students. So this is all about the responsibility of intelligence. Now, AI future predictions 2025 to 2030, that is scientific revolution accelerations, workplace transformations, technical breakthrough, societal impact. Now, I can tell you one example that is recently one teenager. He's going to his school in the morning from 8 to 2 or 4 o'clock. After that, he's coming to his home, taking rest. Then from 12 o'clock onward, he is doing his work for his startup. He is working as a developer. He is working as a chief technical officer. He is working as a looking after the financial task, etc. What he did exactly, he has developed means different agentic model, that is AI agents. He is using the large language models. The large language models is connected with this multiple AI agents using this model context protocols, and he's the only person who is running his startup, and the large language model is looking after all the AI agents, and AI agents are working as this employees, and this is all about the his startup. So this is no doubt an perfect example of the workplace transformations and scientific revolutions too, technical breakthroughs and social impacts. At the same time, we should keep in mind that is the ethical use of the artificial intelligence is very, very important. We are here, we are learning a lot of things because we want to use artificial intelligence for the welfare of the people. Now, preparing for AI tomorrow for beginners means use ChatGPT, Claude. I would request use install Olama and the Mistral. Learn basic Python and the data analysis. Join AI communities for professionals. I would say learn the transformer, then learn the prompt engineering, contextual programming, then attention mechanism, what exactly happening inside the black box, that is this chat GPT, etc. Do fine tune your models, etc. Now for experts, Benz, we can publish our research, share our knowledge, contribute to open source AI projects. At the same time, we can combine this operation research with artificial intelligence. We can combine this operation research with the large language model, etc. Universal principles, continuous learning, critical thinking, ethical consideration, and human centered. That is, keep human values at the centers. So key takeaways and action items, that is the foundation, application, and the frontier I have discussed. AI is a tool, not magic. So keep in mind data quality, algorithm sophistication, human AI collaborations beats either alone, ethics and explainability. So action items is for beginners, for professionals, and for experts. So if you have any questions, you can ask me. That's all in brief. Thank you very much.